Hello everyone. Today we are going to solve NCRT in text questions of Dilution chapter, and this chapter is in class 12th. Solid state is eliminated. This is the first chapter in 2022-23 CBSE board exam. So we will start in text question, NCRT in text question just now. And first question is on your screen. And the question is, yes, beta. First question is, so yes, beta. First question is, calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Right? This is the question. Okay. Wait. See, the question is, first question, calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. To calculate mass percentage, mass percentage of benzene. So mass percentage of benzene is equal to mass of benzene divided by mass of benzene plus mass of carbon tetrachloride into 100. This is the mass percent of benzene. So see, mass of benzene is given to you. Mass of carbon tetrachloride is also given to you. So nothing left. Just put the values. Mass of benzene 22 divided by mass of benzene plus mass of carbon tetrachloride into 100. That is 22 divided by 144 into 100. Means it is 2200 divided by 144. That is 15.28%. 15.28%. This is the mass percent of benzene. Now, mass percent of carbon tetrachloride, that is equal to 100 minus mass percent of benzene. mass percent of benzene. So 15.28 is subtracted from 100 because total mass percent is always equal to 100. So mass percent of benzene plus mass percent of CCl4, that is equal to 100. So mass percent of CCl4 equal to 100 minus mass percent of benzene. So it is equal to 15.28 and it's subtracted from 100, so it's 84.72. This is the mass percent of CCl4. This is the answer of this given question. Okay, 15.28 is the mass percent of benzene and 84.72 is the mass percent of CCl4. Understood? Now question number 2. Calculate the mole fraction of benzene. Calculate the mole fraction of benzene. Calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. So see, what is the question? 30% by mass. Okay, we have to calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. तो मोल फ्रैक्शन निकालना है आपको किसका? 30% ऑफ बाय मास. किसका है 30% बाय मास? 30% बाय मास ऑफ बेंजीन. ओके, so 30% by mass of benzene in CCl4. This is the solution. So in this solution we have to calculate the mole fraction of benzene. So 30% by mass of benzene in CCl4 means, yes beta, what it means? 30% by mass of benzene in CCl4, what it means? It means 30 gram of benzene is present in 100 gram of solution. Present in 100 gram of solution, right? Or how many grams of CCl4? So 30 gram of benzene is present in 70 gram of CCl4, right? See, 30% by mass of benzene in CCl4 means 30 gram of benzene in 100 gram of solution. So total solution is 100 gram, and out of 100 gram, 30 gram is benzene. So what is left? That is CCl4. So 70 gram of CCl4. So now from here, as weight of benzene and weight of CCl4 is given, you can calculate number of moles of benzene, that is equal to mass of benzene divided by molar mass of benzene, and number of moles of CCl4, that is equal to weight of CCl4 over molar mass of CCl4. So see, weight of benzene is given to you, that is 30, but molar mass of benzene and CCl4 is not given. So first we have to calculate molar mass of benzene and CCl4. So molar mass of benzene and CCl4. Molar mass of benzene. What is benzene? C6H6 is 6 into 12 plus 6 into 1, because molar mass of carbon is 12 and hydrogen is 1. So 72 plus 6 means it is 78 gram per mole. So that means it is 30 over 78. Now CCl4. So molar mass of CCl4, that is equal to 1 into 12 plus 4 into 35.5. That is 12 plus it is 154, right? So it is 70 divided by 154 mole. Just divide 30 by CCl. 30 divided by 78. So it is 30 divided by 78 is 0.385. And 70 divided by 154, it is 0.454. So these are the number of moles of benzene and CCl4, and we have to calculate mole fraction of benzene. So mole fraction of benzene is, what is the formula to calculate mole fraction? Mole fraction of benzene is number of moles of benzene divided by number of moles of benzene plus number of moles of CCl4. So number of moles of benzene, it is 0.385 divided by 0.385 plus 0.454. So now 0.385 divided by 0.385 plus 0.454, that is 0.839. So now 0.385 divided by 0.839, that is 0.459. 0.459 is mole fraction of benzene. So mole fraction of benzene is 0.459, and if we add mole fraction, total sum of mole fraction is always equal to 1. In this way you can calculate mole fraction of CCl4 if you would like to calculate. Otherwise, simple question is calculate the mole fraction of benzene in solution. So that is 0.459. That's it. Next question. Calculate the molarity of each of the following solutions. Molarity of each of the following solutions. So molarity of each of the following solutions. First is 30 gram of cobalt nitrate dot 6H2O in 4.3 liter of solution. That means weight is given, weight of cobalt nitrate hexahydrate is given, volume of solution is also given. So what is left? To calculate molarity, what we need first is number of moles of solute over volume of solution in liter. But number of moles are not given. What is given? Mass. So mass of solute divided by molar mass of the solute into volume of solution in liter. The formula. So WB is given. 30 gram. Volume is given in liter, 4.3 liter. Molar mass of cobalt nitrate hexahydrate that we have to calculate. So atomic weight of cobalt, that should be given to you. That is always in the question. Okay, but here it is not given. So you should know that it is 58.9 around. Okay, atomic weight of cobalt is 58.9. Now 2 into nitrate, NO3 negative, NO3. So NO3, there are 2 NO3, right? So 2 into 1 into 14 plus 3 into 16 plus 6 into H2O, that is 18. So it is 58.9 plus 2 into 48 plus 14. 48 plus 14, that is 62 plus 18 into 6, that is 108. Yes, so it is 58.9 plus 124 plus it is 108. So total it comes out to be 108 plus 124 plus 58.9, that is 290.9 gram per mole. Just put the values in this formula. So see, molarity is equal to 30 gram divided by 290.9 gram per mole into 4.3 liter. Answer is in mole per liter. It comes out to be 30 divided by 4.3 divided by 290.9. It is 0.024. 0.024 mole per liter. So this is the answer of part A. Next question is 30 ml of 0.5 molar H2SO4 diluted to 500 ml. See, 30 ml of 0.5 molar H2SO4, it is diluted to 500 ml. Okay, so here we can use dilution formula. What we use? We use dilution formula. What is dilution formula? So dilution formula is M1 V1 equal to M2 V2. M1 V1 equal to M2 V2. Okay. It is for concentrated solution and this is for dilute solution. Okay. So for concentrated solution it is 0.5 and 30. 0.5 molar into 30 ml. So M2 into 500 ml, right? So here M2 is equal to 0.5 into 30 divided by 500. So it is equal to 0.03 molar. So this is the molarity of the dilute solution. This molarity of the dilute solution. 1 second बेटा, बोलो क्या बोलो. ऐसा लिखा है send it, improve your wait. Live session is calculate the mass of urea required in making 0.5 kg of 0.25 molar aqueous solution. So we have to calculate the mass of urea which is required in making 2.5 kg of 0.25 molar aqueous solution. So say 0.25 molar aqueous solution of urea. 0.25 molar aqueous solution of urea means 0.25 mole of urea, 0.25 mole of urea in 1 kg of water, because aqueous solution there, so solvent is water, means 0.25 mole of urea in 1000 gram of water, in 1000 gram of water. And now what is the mass of urea? Mass of 0.25 mole of urea. So first we calculate molar mass of urea. So molar mass of urea is, see what is urea? NH2 CONH2. So there are 2 nitrogen, 2 into 14, 1 carbon, 4 hydrogens and 1 oxygen. 28 plus 12, 4 plus 16. So it is 60 gram per mole. It is 60 gram per mole. Mass of 1 mole of urea, it is equal to 60 gram. So mass of 0.25 mole of urea, that is equal to 60 into 0.25. That means 60 over 4, because 0.25 is 25 over 100. So it is 1/4. So 15 gram. So now it is clear that if we have total 1015 gram of solution, 1015 gram of solution, it requires 15 gram of urea, or we can write that 15 gram of urea is required for 1015 gram of solution. So 1015 gram solution means 1.015 kg of solution requires 15 gram of urea. So 2.5 kg of solution requires 15 over 1.015 into 2.5 of urea, means it is equal to 10 into 2.5 divided by 1.015, that is 36.94 gram of urea. So that means 36.94 gram of urea is required in making 2.5 kg of solution. So means 36.94 gram of urea is required in making 2.5 kg of 0.25 molar aqueous solution. Yes, beta. Any doubt up to this? Yes, beta. Pranay. Any doubt up to this? Means almost 37 gram of urea is required in making 2.5 kg of 0.25 molar aqueous solution. Okay. Next, calculate molarity, and mole fraction of Ki if the density of 20% mass by mass aqueous Ki is 1.202 gram per ml. Calculate molarity, mole fraction of Ki. See, what is the formula of molarity? Weight of solute, molecular weight of solute, weight of solvent, weight of solute in gram per molar mass of the solute into weight of solvent in gram into 1000. So what we need? Weight of solute as well as solvent, and at the same time molar mass of solute. What is solute here? Solute is Ki, and it is 20% mass by mass aqueous Ki, means 20 gram of Ki is present in 100 gram of solution or 80 gram of water. Am I right? 20 gram of Ki, it is present in 80 gram of water. That means weight of solute we have 20 gram. Weight of solvent we have, that is 80 gram. So what we need? We need molar mass of Ki. So molar mass of Ki, there is 1 K, that is its molar mass is 39, and 1 iodine molar mass is 27. So total it comes out to be 166 gram per mole. Just put the values. Molality equal to 20 divided by 166 into 80 into 1000. It is 4. Total it comes out to be 1000 divided by 166 divided by 4. It is 1.51 mole per kg. Right? So this is first part of the question 2.5. That is molality of this solution is 1.51 mole per kg. Now next part is molarity, and molarity we have mass percent as well as density. Mass percent as well as density. So what is the formula? Yes, molarity in terms of mass percent and density. Yes, beta. What is the formula? What is the formula to calculate molarity in terms of mass percent? Yes, molarity is formula. Just keep in mind it is mass percent into density into 10 over molar mass of solute. This is the formula. Calculate molarity of the solution in terms of mass percent and density. So mass percent is given 20. Density is also given, that is 1.202 into 10 divided by 166. So it is 20 into 1.202 into 10. So 240.4 over 166. It is 1.45. And its unit is mole per liter. So molarity of the solution comes out to be 1.45 mole per liter. Now third part, it is calculate mole fraction of Ki. So say to calculate mole fraction of Ki, what we need? We need number of moles of Ki divided by number of moles of Ki plus number of moles of water. These values are required, means number of moles of Ki and number of moles of H2 are required. But we have weight of Ki and weight of H2O. From the percentage we calculated, and 20% of Ki is given. That means 20 gram of Ki in 100 gram of solution That means 20 gram of Ki in 80 gram of water. So, you know molar mass of Ki, it is 166 gram per mole. Molar mass of H2O, that you also know, 18 gram per mole. Okay. So from here, number of moles of Ki is 20 over 166. That is, it is 0.12. And number of moles of H2O, that is 80 over 18. That is 4.44. Just put the values. 0.12 divided by 0.12 plus 4.44. 0.12 divided by 4.56. It is 0.026. Yes, beta, just confirm the answer. Is it okay? Hello? Yes, beta. Just confirm the answer. 0.5 first is 1.5 molality is 1.51 mole per kg, okay? 1.45 mole per kg and 0.026. It is also in 0.063 is a mole fraction of Ki. Sixth question is related to Henry's law, which is eliminated from the syllabus. We will not solve this question. Again, 0.7 is also from Henry's law. So this Henry's law is not in the syllabus now. This is eliminated from the syllabus. Now 2.8, vapor pressure of pure liquids A and B are given to you. Find out the composition of the liquid mixture if total vapor pressure is 600 mm Hg, and also find the composition of the vapor phase. Vapor pressure of pure liquid P naught A is 450 mm Hg. P naught B 700 mm Hg at 350 Kelvin. First, we calculate the composition of the liquid mixture. Composition means we have to calculate XA and XB. Obviously, if one of them is known, other can be calculated easily, because XA plus XB, that is equal to 1. Okay. Okay. So now total vapor pressure is given to you. Total vapor pressure is 600 mm Hg. Now total pressure is given, P naught A is given, P naught B is given. From these values, we can calculate XA and XB. How? We know that P equal to PA plus PB according to Dalton's law of partial pressure, and PA, P naught A XA, P naught B XB according to Rawls law. Then it is 1 minus XB, P naught B XB. So P is equal to P naught A plus P naught B minus P naught A into XB. That's it. So now P is given, total pressure is given, total vapor pressure. P naught A is given, P naught B is given. Just put the values and you will get XB. The P is 600. Now it is 450 plus 700 minus 450 into XB. So it is equal to 600 minus 450. So now is 250 into XB. That implies 150 equal to 250 into XB. It means XB equal to 150 over 250. Means 3 by 5 means it is 0.6. So XB equal to 0.6. So XA equal to 1 minus XB, that is 1 minus 0.6 means 0.4. So in this way, this is composition of the liquid mixture. Keep in mind, composition of the liquid mixture means mole fraction of components in the solution. That is 0.4 and 0.6. XA is 0.4, XB is 0.6. Now next part is also find the composition of the vapor phase. Yes. Now liquid mixture composition is mole fraction of the components in the solution. Now composition of the vapor phase means mole fraction of the components in the vapor phase. First was mole fraction of the components in the solution. Now composition of the components or mole fraction of the components in the vapor phase. So how do we calculate? YA, mole fraction of component A in vapor phase. So that is equal to PA divided by PA plus PV. YA equal to PA divided by PA plus PV. So PA equal to P naught A XA divided by P naught A XA plus P naught B XB. What is P naught A? P naught A is 450 and XA is 0.4. 450 into 0.4 plus 700 into 0.6. Okay. So now 450 into 0.4 700 into 0.6. 180 divided by 600. So it is 6, okay, divided by 10, that is 0.3. 0.3. Now, Ya plus Yb, mole fraction of A in vapor phase plus mole fraction of B in vapor phase, that is also equal to 1, because total sum of mole fractions is always equal to 1. It is in the solution or in the vapor phase, that is same. So Yb now equal to 1 minus Ya, that is 1 minus 0.7, sorry 0.3. It comes out to be 0.7. So now mole fraction in vapor phase, Ya equal to 0.3, Yb equal to 0.7. And in the solution phase, it was Xa 0.4, Xb 0.6. That's it. This is in the vapor phase, and this is in solution phase, right? Now question number 2.9. Vapor pressure of pure water at 298 Kelvin is given to you. Means P naught A. Let us say A is solvent and B is solute. What is solvent? Water, and solute is urea. Okay, so P naught A is 23.8 mmHg, 50 gram of urea. That means WB is 50 gram, is dissolved in 850 gram of water. To calculate the vapor pressure of water for this solution and its relative lowering. Okay, calculate the vapor pressure of water for this solution and its relative lowering. So to calculate vapor pressure according to Raoult's law, PA, that is vapor pressure of water in the solution, that is equal to P naught A XA, and relative lowering of vapor pressure, that is P naught A divided by, what is the formula for relative lowering of vapor pressure? See, PA equal to P naught A into 1 minus XB. That implies PA upon P naught A to 1 minus XB. So XB equal to 1 minus PA over P naught A. That is P naught A minus PA over P naught A. So this is the formula actually. So relative lowering of vapor pressure is P naught A minus PA over P naught A, and it is equal to mole fraction of the solute. That we have to calculate. Is we calculate XB, XA. If we calculate XB, that is the relative lowering of vapor pressure only, and PA. So that means now P naught A we have, but XA we don't have. Now we expand XA. XA equal to NA upon NA plus NB. But NA and NB are also not given to us. So we further expand it. NA equal to WA by MA. WA is given to us. So we need MA. NB, WB by MB. WB is also given to us. So we calculate MB. So just write the values of MA, that is molar mass of water. So molar mass of water is 18 gram per mole, and molar mass of urea NH2CONH2, it is equal to 2 into nitrogen weight, atomic weight, that is 14, 4 into hydrogen, 1 into carbon, 1 into oxygen. So total comes out to be 60 gram per mole. We have already calculated it, right? So now Na. Now we go back. Na Wa by Ma. What is Wa? 850 gram. And molar mass is 18. So 850 by 18. It comes out to be 47.2. Now NB. WB by MB. What is WB? 50. Divided by 60. 50 by 60. So it is 0.833 mole. So from Na and Nb, we can calculate XA, because we need XA as well as XB. So you can calculate XA or XB. So XA equal to 47.2 divided by 47.2 plus 0.833 is 47.2 divided by 47.2 plus 0.833, 48.033, 47.2 divided by 48.033, that comes out to be 0.983. So this is the mole fraction of water. And what is mole fraction of urea? Obviously it is 1 minus XA. One minus 0.983, that is 0.017. XB equal to 0.017. It is XA and XB. And this is relative lowering of vapor pressure. So relative lowering of vapor pressure is P naught A minus PA by P naught A, that is equal to 0.017. And what is PA? So PA equal to P naught A into XA. P naught A is 23.8. 23.8 kilo mmHg. And XA is 0.983. So PA, that is vapor pressure of water. that is equal to 23.395. You can write it as 23.4 mm Hg. So these are the answers. That vapor pressure of water in solution 23.4 mm Hg, and relative lowering of vapor pressure is 0.017. Okay. Next question, 2.10. So in 2.10, it is boiling point of water at 750 mm of Hg, that is 99.63 degrees Celsius. Boiling point of water at 750 mm Hg. It is given to you, it is 99.63 degrees Celsius. So how much sucrose is to be added to 500 gram of water such that it boils at 100 degrees Celsius? That means T naught B is equal to 99.63 degrees Celsius. That is boiling point of pure water. Because pressure is reduced. See, 750 mm of Hg. At 760 mm of Hg, it is 100 degrees Celsius. But pressure is reduced, so its boiling point is also reduced. So boiling point of pure water is 99.63 degrees Celsius, and when sucrose is added, it is raised to 100 degrees Celsius. So we have to find out that how much sucrose is to be added to 500 gram of water such that it boils at 100 degrees Celsius. So delta TB, that is, what is this? Elevation in boiling point. That is one of the colligative property. That is equal to TB minus T naught B. TB is 100 minus 99.63. So 100 minus 99.63. So it is 0.37. So this is delta TB. It can be written as Kelvin or degree Celsius because change in temperature remains same. Either it is in Kelvin or degree Celsius. Okay, because it is a change. Now we know that delta TB equal to kbm because sucrose is non-electrolyte. So Van't Hoff factor does not play any role. It is equal to 1 only. Okay, so delta TB equal to kbm, but small m molality is not given. Kb is molar elevation constant. So Kb into the expanded further molality equal to weight of solute in gram, molar mass of the solute, weight of solvent in gram into quotient. Okay, so now WB, that is weight of sucrose, that we have to calculate. Weight of solvent, it is given to us. Weight of water is given to us because A is solvent and B is solute. Now, molar mass of sucrose. What is sucrose? C12H22O11. So it is 12 into 12 22 into 1, 11 into 16, 144, 22, 176. So it is 342 gram per mole. This is MB. Now what is not given? KB. KB should be given to us. KB of water, it is generally known to us, KF and KB. Okay, otherwise you can note down it. Okay, KB of water. So KB of water is KB of water. It is 0.52 Kelvin kg per mole. It should be given to you. It is molar elevation constant. Okay, it is molar elevation constant. So now everything is with us except WB that we have to calculate. Just put the values. So this is the equation: delta TB equal to KB WB MB WA 1000. Delta TB is 0.37, KB is 0.52, WB we have to calculate, MB 342, WA, yes, WA it is 500, it is 2, so WB equal to 0.37 into 342 over 0.52 into 2. So 0.37 into 342 over 1.04. So WB is 121.67 gram. So this much of sucrose is to be added to 500 gram of sucrose such that water boils at 100 °C. Okay, so it is 121.67 gram or almost 121.7 gram. Next question. Calculate the mass of ascorbic acid, that is vitamin C, C6H8O6, to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. Here Kf is given to us because solvent is other than water. Okay. Now what we have to calculate? Again mass. In the last case it is mass of sucrose. Now in this case it is mass of ascorbic acid. WA it is 75 gram, and to lower its melting point by, that means lowering of freezing point. So depression in freezing point is 1.5 degree Celsius. 1.5 degree Celsius. Kf is given. So Kf is 3.9 Kelvin kg per mole. Okay, Kelvin kJ per mole. So delta TF is equal to KF into M. That is KF into WB by MB WA into 1000. Now just put the values. WB we have to calculate. WA is given to us. Now MB. MB is molar mass of ascorbic acid. That is 6 into 12, 8 into 1, 6 into 16 is 72 plus 8 plus 96 is 176 gram per mole. So delta TF is 1.5, TF is 3.9, WB we have to calculate, and MB is 176 and WA 75 into 1000. So WB is equal to 1.5 into 176 into 75 divided by 3.9 into 1000. So WB equal to 1.5 into 176 into 75. 3900. 5.077 gram. So this is the mass of ascorbic acid to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degree Celsius. Okay. Last question. Calculate the osmotic pressure in pascals. See, this is the SI unit of pressure exerted by a solution prepared by dissolving 1.0 gram of polymer of molar mass 185,000 in 450 ml of water at 37 degrees Celsius. So we have to calculate the osmotic pressure. So you know, osmotic pressure is equal to TRT. The concentration is not given. Temperature is given in degrees Celsius. T, capital T means temperature in Kelvin. So we can convert it easily. Now, C, you know what is C? Number of moles over volume of solution in liter into RT. Now, number of moles are also not given. So we expand it further. Weight over molecular weight into volume of solution, it is given in ml. So it is multiplied by 1000 into R into T. So just see what is given to you. WB is given. WB is 1 gram. Weight of solute. And molar mass, it is 185,000 gram per mole. Volume of solution for 50 ml. And temperature temperature equal to 37 plus 273.15. Keep it like this only. So 0, it is 310 Kelvin. Now R. So now we put value of R. You know R is 8.314 joule per Kelvin per mole. Capital R is 8.314 joule per Kelvin per mole. So now joule is energy unit. It is equal to 8.314 kilopascal, right? Joule is energy. Okay, energy is what is the unit of R in terms of Pascal we need, right? So R is 8.314 joule per Kelvin per mole, right? So it is equal to kilopascal liter per Kelvin per mole. So it is equal to actually 8.314 into 10 raised per 3 Pascal liter per Kelvin per mole. See, this is this VML over 1000 means volume in liter. Okay, so R in place of 8.314, now we write 8.314 into 10 raised per 3. Only this is the twist. Rest is same. So pi is equal to WB, that is 1 gram, 185,000, that is gram per mole. Then volume 450 ml, 1000 ml per liter. 1000 is ml per liter into 8.314 into 10 power 3 Pascal liter per Kelvin per mole into 310 Kelvin. So see, gram cancel, ml cancel, per mole cancel, liter per liter cancel, Kelvin per Kelvin cancel. So what is left? Pressure in Pascal. That is pi equal to 1.0 into 1000 into 8.314 into again 1000 into 310 divided by 185,000 into 450 Pascal. That means it is equal to 1000 into 8.314 into again 1000 into 310. Oh my God. Just remove these 3 zeros. Okay. 1 0, that can also be cancelled. That means it is 1000 into 8.314 into 31, 257,734 divided by 185 into 45, that is 8325. So now it is 257,734 divided by 8325. That is 30.96. 30.96 Pascal. That is the pressure, osmotic pressure. Okay, 30.96 Pascal. So these are the all NCRT in text questions. Okay, beta. Yes, beta. Did you understand? Okay, then thank you. So these are the total questions. Right? Okay, so these are total 10 questions because questions related to Henry's law we have not done because they are not in the syllabus now. These are all NCRT in-text question of solution chapter. They are also very important from the examination point of view. So don't leave them aside. Just solve them. Just learn how to approach the question and how to solve them. Okay, that's all. Thank you so much. And don't worry, beta, even if only one student is watching, it is worth for me. It's my hobby. Continue, teach, make the students learn. And there are so many options available in the market. So whosoever feel comfortable in my way of teaching can watch and enjoy learning and can be benefited. That's it. Thank you so much to all of you. Those who support my channel, it is a free education drive. So enjoy learning free of cost. I'm not charging a single penny to anyone. It is all free of cost. Is I'm saving your hefty amount of money that you are spending in coaching institute. Just take benefit of all this. Okay, that's it. That's my aim. Really. Thank you so much. Have a nice day. Bye bye.